All right, let's jump right in. We need to talk about the absolutely insatiable energy appetite of artificial intelligence. And one company's pretty radical bet on how to power it. That company is Oklo. This is really a story about a potential solution to the coming AI power crisis, and it involves a whole new kind of nuclear energy.
So when you use an AI tool, when you're chatting with it or generating an image, what are you really plugging into? It's not just some algorithm floating in the cloud. No, it's a massive physical infrastructure of data centers that are chugging down an astonishing amount of electricity.
And here's the scale of that problem. By 2030, the world is expected to need somewhere around 100 gigawatts of new power capacity just for data centers, and that's largely driven by AI. To put that in perspective, that's like adding the entire power grid of a country like Germany. The demand isn't just growing, it's absolutely exploding.
Now, this is where it gets really tricky. You see this fundamental mismatch, right? On one hand, you've got renewables like solar and wind. They're great, but they only generate power when the sun is shining or the wind is blowing, maybe 25 to 40% of the time. But an AI data center, it needs to be on, running at full tilt 99.9% of the time. This creates what the industry calls the baseload gap, a desperate need for constant, reliable, 24/7 power that intermittent sources just can't fill on their own.
So how in the world do you solve for that gap? Well, this brings us to Oklo and their completely different approach to providing power for this new AI age.
Their entire business model is something called power as a service. So instead of trying to sell a billion-dollar reactor to a company like Meta, Oklo says, hey, don't worry about that. We'll build it, we'll own it, we'll operate it. Their customers just sign a long-term contract to buy the electricity. It's kind of like a subscription. This totally removes the massive upfront cost and the operational headache for the data center owner.
So what's the actual technology that makes this all possible? Well, at the heart of Oklo's whole plan is their reactor, the Aurora powerhouse. The best way to think about it is like a small, incredibly powerful nuclear battery that's designed specifically for this kind of dedicated, always-on power.
Okay, now the Aurora is what's called a fast spectrum reactor. That sounds complicated, but here's the simple version. Unlike traditional reactors that use water to slow down neutrons, these reactors use them at full speed. This lets them wring way more energy out of their fuel. And here is the absolute game changer. They can run on the spent fuel, what we call nuclear waste, from the existing fleet of reactors. And this little chart just lays out the difference perfectly. A conventional reactor uses high-pressure water as a coolant. The Aurora, it uses liquid sodium, which can operate at normal atmospheric pressure. That right there eliminates a major safety risk. But the most important part is the waste profile. It's designed from the ground up to recycle fuel, unlike the use it once and store it cycle of today's plants.
And this all comes together in what they call their closed-loop fuel cycle. Now, Oklo starts with a special new fuel called HALEU, but their long-term vision is to take what is currently considered high-level nuclear waste, reprocess it, and turn it into new fuel for their reactors. They literally want to transform a multi-billion-dollar national liability into a massive strategic asset.
So what about safety? That's the first question with anything nuclear, right? Well, the Aurora's design leans heavily on something called passive safety. It means that if the reactor starts to overheat, the fundamental laws of physics, the way the materials themselves behave, cause the core to expand, and the reaction automatically slows down and stops. No buttons to push, no pumps to fail, no electricity needed. Physics itself does all the work.
Okay, this all sounds great on a PowerPoint slide, but is anyone actually buying it? Well, this is where the story connects right back to the AI boom in a very, very big way. Not long ago, Meta, the parent company of Facebook and Instagram, signed on with Oklo. They're exploring the development of a 1.2 gigawatt nuclear energy campus in Ohio. I mean, just to be clear, that's a truly massive amount of power dedicated entirely to whatever their future AI infrastructure is going to be.
And you really can't overstate the significance of this. The deal is being called a transformative validator for Oklo's entire power-as-a-service idea. It's a huge signal to the rest of the market that one of the biggest tech companies in the world sees this as a serious, viable solution to their energy problem.
And it's not just Meta. If you look at Oklo's pipeline of potential customers, yeah, hyperscale data centers are the biggest piece of the pie, but they're also targeting big industrial users, the US military, and even remote communities that are off the main grid. All told, the expressed interest in their pipeline has already hit over 18 gigawatts. But let's be crystal clear here, this is a super high-risk, high-reward venture. Success is absolutely not guaranteed, and Oklo is facing a gauntlet of immense challenges.
You can really boil it down to 4 huge risks. First, regulatory. The U.S. Nuclear Regulatory Commission, the NRC, has never, ever licensed a commercial fast reactor before. Second, technology. While the concept is proven in labs, scaling liquid sodium cooling for commercial use is really complex. Third, supply chain. That special HELU fuel it needs, it isn't really produced at scale in the West. Yet. And finally, capital. This all costs billions and billions of dollars to build.
So the company's future is, well, it's pretty binary. It could be a massive success or a spectacular failure. So here are the key milestones you need to watch that will really determine which path it takes. The next 2 years are absolutely critical. In 2026, we're all watching for their first pilot reactor to go critical at Idaho National Laboratory. That's a huge step. Then we need to see key safety approvals from the NRC. If those 2 things go well, the grand prize is getting that first commercial license, which they're hoping for in 2027 or 2028.
And this table basically lays out the potential outcomes. In a best case, or bull scenario, fast approvals and successful scaling could lead to a company valued at over $25 billion. The bear case, crushing regulatory delays, caused the company's value to just plummet. The base case kind of assumes they just execute steadily and get their first commercial units online in 2028.
So what are the absolute deal breakers? What could kill this whole thing overnight? It really comes down to 2 things. First, a second flat-out rejection from the NRC would be devastating. And second, any major technical failure in their pilot reactor that proves their passive safety claims are wrong. Either one of those would just fundamentally break the entire investment case.
Which really leaves us with this final massive question. AI's need for power is growing at a mind-bending rate. So to meet that demand without just burning more fossil fuels, is a high-risk, high-stakes bet on advanced nuclear like Oklo's not just an option, but maybe an absolute necessity for a sustainable digital future?